All right. So I have some questions on Webassign with capacitors. And so specifically around part B. We're going to do number 2, part B, number 3, and number 4. Okay, so 2B says, what's the energy stored in each capacitor? Well, there's a couple different ways to do energy in a capacitor. So, I'm going to write it up here, a little more space. So U equals 1/2 QV is the standard equation. The other one is by substituting, we could have 1/2 CV squared. You notice both of these have voltage. And where this problem gets difficult is the voltage is 1.54 volts between those 2 points. It's not saying that the voltage of each of those is 1.54. If this guy wasn't there, that would be true. Because then it would just be the two of them in parallel. But since that guy's there, it messes it all up. So instead, since C is Q over V, and in part A, you solve for Q. I want to try to leave it in Q. I want to get rid of V. So V is Q over C. So I'm going to get this guy out of here. So see with my initial equation here, what I'm going to do is I'm going to substitute in. So 1/2 Q times V. 1/2 Q squared over C. Knowing your charges that you solve for in part A, you can plug them in and plug in the capacitance. The reason why a lot of people are getting the wrong answers on this is they're using the entire voltage, the entire potential difference for each of them, which is not true. It's the same for these two, but right, you haven't solved for what it is on those. So there you go. There's 2B. That might be what the question was. If it's not, please reach out to me and I'll add to this. Let me clear this all out. And number 3. 3, I thought I had a simple answer for it, and then I finally read it. I forget who I was working with, but they brought up, they're like, Shmir, that's not exactly what it says. I thought it was saying 120 volts across the whole thing. No. Oh, sorry, 125. Sorry. Instead, the individual can only have 125. And the person I was talking to said, Shmir, that first capacitor, that's going to be your limiting factor. Because if I put 125 volts on that, that's going to get a certain amount of charge. That'll work for the rest of them. But if I were to use the bigger ones, it's going to mess it all up. So here's a couple different big ideas on this. So one is when we have capacitors in series, the charge overall will be the charge on this plate, will be on this plate, will be on this plate, will be on this plate, this plate, and this plate. Now when I say charge, well, if this is positive over here, that'll be negative. That'll be positive. This will be negative. That'll be positive. This will be negative. And so the key is you're separating that much charge onto the plates. And so whatever charge you solve for, that's the one you'll use for everything. So we're going to use that. C is Q over V. So this C is 10.3 microfarads equals Q over V. Because if I apply 125 volts to that capacitor, that's the maximum amount of charge I could have. So I solve that out and I get Q is, let's get a number to work with. You remember, you have slightly different ones. So 10.3 times 125 times 10 to the negative 6, I get 0.00129 coulombs. Now, that's a start, okay? We haven't even talked about energy yet. So watch this. That's the same amount of charge that's going to be on this guy. That's the same amount of charge that's going to be on this guy. Okay, so that's their charges. Now, I need to find energy. Well, energy is 1/2 QV. I know what Q is. This first guy I know what V is, right? So I can just plug that in. But remember the last question we talked about, we substituted in. I'm going to get Q squared over C. That's going to be a little bit easier. So I can plug in that Q and square it, and then divide it by the C and 1/2. Big thing is when you do that, Q is 00129 squared all over C. So my first one is 10.3 times 10 to the negative 6. So that is where you got to be careful. Make sure that if you're using a TI calculator, that is in parentheses. If you're using these guys, make sure it's in parentheses. So you end up dividing by it. All right. I think that does it. Again, reach out and let me know if it doesn't do it. All right. Here we go, last one. Consider the circuit below. The potential difference across A and B is 120. I got something to work with there. And the capacitance are as follows. Sweet. Initially, the capacitors are all uncharged. Okay. As I charge this thing up, the first question is how much charge flows onto it. So we're going to use the idea that C is Q over V. So the amount of charge is CV. Well, I need to know what the total capacitance is because I know what the total potential is, 120. So I can use that, but I need to know what my C is. All right, so C1 is 11, C2 is 7, C3 is 2, C4 is 19. So to find my total, these guys are parallel, so I add them together. I get 20. So that one up there is 20. Connected to this one down here, which is 19. So I do 1 over C is 1 over 20 plus 1 over 19. Really close to the same. So 1 over 20 plus 1 over 19. 1 divided by that, I get 9.7. So my total capacitance is 9.7 microfarads. I still have my micros, don't forget those. So 9.7 times 10 to the negative 6. So that'll give me my total charge. Let's talk about where we can use that. That total charge is here. So that's right. Let's say it's positive. On this side, it'll be negative. But here's the problem. That charge is going to get split up by these. So this one will get 2 out of 20. This one will get 7 out of 20. And this one will get 11 out of 20 of the charge. So when I have that charge, when I have that number, this number here, Q, I'm get 9.7 times 120 times 10 to the negative 6. I get a charge of 0.001164 coulombs. Okay, I might have rounded wrong. Forgive me if I did. Let me know if that affected the answer on Webassign. So that means this guy has that much charge on it because that's the charge that flowed onto it. But on the other side, it got split between those different conductors. And so this one used to do 2/20ths. This one was it 7/20ths? Sorry for making that sloppy. And this one's 11/20ths. I think I'm going to double check that that is all that question was asking. Yes. So again, hopefully that hit the ideas. If it didn't, just let me know. Okay, but I think I tried. But if I need to think of it a different way or if I have something wrong, please reach out and let me know. Happy to help you guys. Okay, talk to you guys later.